In this video, we're going to continue talking about transformations of functions. And so let's take a look at learning objective for this section. That's graph functions using vertical and horizontal shifts, graph functions using reflections about the x-axis and the y-axis, determine whether a function is even, odd, or neither from its graph functions using compressions and stretches, and combine transformations. We already started talking about it. So in these and this video and the following videos, we're gonna basically look at what we already know from a slightly different angles. So all right, so this is what we already know about shifts. So the function in blue is our cube root function. And we know that if we add 1 on top of that function, it shifts up 1 unit. All right, so we already know that about the function transformation. So let's take a look at this example. How this example is different is we are not given a formula for a function, but instead we are given a picture, okay, a graph. So let's read the scenario. It says to regulate temperature in a green building, airflow vents near the roof open and close throughout the day. The picture shows the area of open vents, V, in square feet throughout the day in hours after midnight, T. During the summer, the facilities manager decided to try to better regulate temperature by increasing the amount of open vents by 20 square feet throughout the day and night. Sketch a graph of this new function. So we are not given a formula, as I already mentioned. We are given a graph. How do we approach this? Let's see. Here we are. So let's break it down a little bit. What's going on here? I want to remind you that we have a time t on the x-axis. On y-axis, we have amount of vents. So here it says that to better regulate temperature by increasing the amount of open vents by 20 square feet throughout the day and night. So mean for all t values for on the entire domain of this function, for all t values, we're gonna increase the v, right, by 20 square feet. So that means that this function is gonna increase by 20 everywhere. So every point is gonna move 20 units up. So right here, since this is 50, I would say that 20 would be somewhere here. So, and we're gonna increase every point by that amount. Every point where the function changes somehow will be moved up, okay? And we're gonna get our new function by connecting those points. And this is a function that we got as a result. So sometimes the functions could also be given in a table, in the form of a table. So let's see what we do in that case. So how to, given a tabular function, create a new row to represent a vertical shift. So step 1, identify the output row or column. Determine the magnitude of the shift. meaning by how much we're going to shift it, and is it going to be up and down? And 3, add the shift to the value in each output cell. Add a positive value for up or negative value for down. Okay, so let's take a look. A function f of x is given in a table. Create a table for the function g of x, which is f of x minus 3. Then graph both functions on the same coordinate system. Okay, so here I have x values and I have f of x. So f of x is the output values. So x is input, f of x is output. I'm going to create a new row that will represent the outputs for g of x. And what does g of x does? G of x takes f of x, the outputs for f value, and subtracts 3 or shifts down 3 units. So I'm going to take each output right here and shift it down 3 units. So 1 minus 3, that's going to give me a negative 2. Right. And then I have 3 minus 3, that is going to give me an output of 0. 7 minus 3 will give me an output of 4. And 11 minus 3 will give me an output of 8. Okay, so these are the outputs of my new function. The inputs are going to be the same, 2. If the input is 2, the output for g of x is negative 2. If input or x value is 4, the output for g of x is 0, and so forth. Now let's graph it. I already have a graph of function f. So I'm going to copy the values of g of x here. So here we are, just copied this table that we got in the vertical format. So let's graph it. So for g of x, I have 2, negative 2, and then 4, 0, 6, and 4, and 8, 8. So here we go. This is the graph for g of x. Okay, so as you can see, each point was moved 3 units down. That's how we ended up with g of x. Here, I would like you to ponder over this question for a couple of minutes. It says shifting a function vertically. A function h of t equals negative 4.9 times t squared plus 30t gives the height h of a ball in meters thrown upward from the ground after t seconds. Suppose the ball was instead thrown from the top of a 10-meter building. Relate this new height function, b of t, to h of t, and then find the formula for b of t. So I want you to pause here and try and solve this problem. Okay, so here I got a picture for our thrown projectile, and that follows that path of the height of above the earth at any given second. Let me actually, any given time. So that's h of t1. This is going to be h of t2, h of t3, so forth. So the height at any time is determined by this formula. Now, this same object is thrown from the, what does it say? 10-meter building. So we have 10 meters here, 10-meter building. So it's thrown from the 10-meter building with the same force. So this is its trajectory. So basically it flies on the same path, only it starts higher. And this is our function b of t. So what happens, what's gonna happen, that this equation is gonna move up 10 meters, right? So the height will be added here. All right, so our b of t is gonna be h of t plus 10. So what exactly that's gonna look like? We're gonna grab our h of t, negative 4.9 t squared plus 30t, and then add 10 on top of it. So that's our new function, b of t. Did you get that? I hope you did. If you have any questions, let me know. And I'll see you in the next video.